Solving logarithm equations. Part 1. When you solve logarithm equations, you need to keep in mind the fact that logarithms are inverses of exponentials. So we really have two different processes we can use to solve logarithm equations. One process is to exponentiate both sides of the equation. That means you take whatever is there and make it an exponent. So if we look at the first problem here, this is a regular, what we call common log, which means the base here is understood to be 10. So to exponentiate this, I would want each side of the equation to become the exponent with a 10. So I would have 10 to the log of x power equals 10 to the 5th power. The reason I choose 10 here is because your 10 and your log base 10 are inverses of each other. So this side would become just an x. So we would have x equals 10 to the 5th power. And 10 to the 5th power is 100,000. If we were to look at this problem, the natural log of x equals 5. Here our base is understood to be an e. So to solve this equation by using exponentiation, I would make each side of the equation the exponent with an e. So I would have e to the natural log of x power equals e to the 5th power. And here, once again, my e and my natural log undo each other. So I just get x equals e to the 5th power. Now, e to the 5th power would be considered the exact answer. If you wanted the decimal approximation for some reason, you would do, in your calculator, second natural log 5. That would give you e to the 5th power. That would be approximately 148.41. Now, let me show you another process you can use. Sometimes I think this process may seem a little easier to do. Here I have the same equation, log of x equals 5. If you remember that we can always convert a logarithm equation into an exponential equation using this, well then once you have your equation in the form of the logarithm on one side and numbers on the other side, you can just rewrite that as an exponential equation. In this case, my a is my base, which is 10, and my k is the 5. So this equation would become 10 to the 5th power equals x. That's exactly what I got over here. So that would be my solution. 100,000 would be x. Now down here on this equation, remember my base is e. So I would rewrite this as e to the 5th power equals x, which is the same thing I have here. Let's look at an equation that has a little more stuff in it. Here, my first step needs to be to get my log part by itself. So I want to get rid of this 5. I'm going to subtract 5 from both sides of my equation. That's going to give me 2 times the log base 2 of x plus 3 equals 4. Now here, I still don't have my log quite by itself. I've got this 2 here in front, so I'm going to undo this multiplication by dividing by 2. So that gives me the log base 2 of x plus 3 equals 2. Now, this is in the same form those other ones were in. I have my base is 2, so I can rewrite this as 2 to the second power equals whatever you're taking your logarithm of is x plus 3. So now I have an equation to solve. 2 squared is 4. 4 equals x plus 3. Now I subtract my 3 from both sides to get that x is 1. Now, one thing I didn't mention on the other problems that I need to mention, it doesn't apply here yet, but it will on some equations, is you must check your solutions to your logarithm equations. Sometimes you'll get a solution to a logarithm equation that doesn't work. In this case, and in all of these problems, they do work. But occasionally they won't. So let's go through this checking process. To check means I'm going to plug it back into the original equation. And I want to make sure that my left side of my equation equals my right side. So if my x is 1, I would have 5 plus 2 log base 2 of 1 plus 3 is 4. So this is 2 times the log base 2 of 4. Well, let's see here. I think I can think about this one for a little bit and get this in my calculator or in my head. The log base 2 of 4 would be the log of 4 divided by the log of 2 using the change of base formula, which is 2. So this is 5 plus 2 times 2, 5 plus 4, which is 9. And on the other side of the equation, the 9 is what you have. So it does check.